Tonight we have a lot of speakers. So we have speakers from Milvus, which is myself. Then we have speakers from Neon. We have speakers from Google Cloud, Gatling, Docker, and Influx Data. So I'm just going to start with a quick intro, of who Milvus is and everything, and myself. Then we'll start with the speakers, right? So if you don't know me, I'm Stefan. I'm a developer advocate at Milvus. I organize those meetups every month. I also organize the MLOps community meetups, so you might have seen me in those. In October, we'll also organize the biggest hackathon that Berlin has ever seen. So follow me and then you'll see it happen. We're expecting, it's a big partnering with Meta. We should have about 400 to 500 people coming. So that's basically what I do in Berlin. I organize a lot of events, a lot of talks. And yes, it's not online yet, but it should be soon. But code of conduct as well, please be respectful and kind with everyone. Also, if you want to share anything, improvements or anything, all ideas are welcome. If anyone is not appropriate, please report it to either myself or someone from Google. So yes, just be kind to each other and then everything will be fine. If you don't know what vector databases are, we have Getting Started for Milvus, which is the open source version we have. And then Zilliz Cloud, which is the cloud offering we have. So it's like Milvus, but fully managed. So also Milvus is fully available on GitHub, so you can check that out directly. Also, we're hiring for developer advocates in different cities in the world. So if you have a fan, or if you want to move to Tokyo and San Francisco, actually, then you may talk to me after, or then you can just directly go on our website. We're hiring for solution architect as well, software engineers in different parts of the world. So have a look if you're looking for a new job. We're also on Discord. If you ever have any questions related to Milvus, we offer free support. So if you even if you're running Milvus for your company, you can just chat with us directly on Discord. I will be happy to help you. We usually have a lot of engineers there, so our head of engineering is also present, and different cool people that can really help you. If you ever want to become a speaker, feel free to scan this one. It's we do those, as I said, every month. So the next one, except August, because I'm taking a break, but the next one is beginning of September, and then we'll have one in October and then one in November. So yes, feel free to become a speaker if you want to. We always usually have cool events, always looking for new venues. Also, if you want to become a venue, if you want to host us in the future, feel free to reach out to me, because we usually always change venues, so people are not bored, but then we look for big venues, basically. If you ever used Milvus and built something, also feel free to reach out. Who knows Milvus here? Raise a hand. Yay! Very proud. Okay, cool. Who has used Milvus? Some people. Okay. So maybe you can get socks if you used it a bit. But yeah, if you used it in the past, feel free to share it. We'll be happy. I have a lot of swag that I can give away. And talking about swag, so part of my job is to promote the open source community, and we are obviously on GitHub. So we have a big prize to make we have prizes for winners at the end. I have some swag. So if you want the chance to actually win some swag, you can scan this QR code, and then I have the wheel at the end. When we play the game, and then I can announce the winners. So I leave it on for a couple of minutes. No, not a couple of minutes, a couple of seconds. So you can check it out, and then at the end we'll have the wheel, and then yeah, maybe you can get socks. I think I still have some t-shirts, and if you come to the next one, then I have hoodies as well, but for now they are in transit. All right, yeah, please share your pictures. Therefore, if you do so, my manager will be very happy, because I'm paid to promote open source. So if you share your pictures online, then everyone will be happy, and I will be extremely happy. Tonight, we have a lot of speakers, so we have 6 talks actually. So we'll have Raouf in the first place, which is working at Neon. Then we have Nikolai working at Google Cloud. Myself, I will also come back on stage later, talking about Milvus. We have Oleg, which is from Docker, Zoe from Influx Data, and then to close it, Samir from Gatling. So we have a very busy event. We'll try to make it not too late as well, so you can have networking in the end. But yes. If you want to join us at our next meetup, feel free to join us, but you should already be in the group. I'm going to call our host tonight. I'm going to call Jakob. You have a presentation from Google. Thank you, everyone.
Cool. Thank you very much for everyone being here. Super awesome seeing you, so many familiar faces as well. Sorry again for the sign-up process. It was a bit of a mess. We'll work on improving that for sure. Anyways, super nice seeing you. It's amazing to see the Berlin community grow so much. Yeah, super cool to see a lot of good collaborations. I don't have too much to say, honestly, from Google side. I'm personally, maybe one word to myself. I'm a customer engineer and AI specialist working with our cloud customers. So if you should have any questions regarding Google Cloud or the Google Universe and what we're doing in the AI, LM, or any other space, feel free to come up to me. Feel free to come up to my colleague Nikolai, who's also going to be on stage later. And yeah, let's chat. Let's connect. And with that, I'll open up the stage to the first speaker. Right?
Thank you very much. And yes, our first speaker will be Raouf from Neon, which is going to talk about RAG using pgvector. So, Raouf, the stage is yours.
Right. It's working? Can everybody hear me all right? All right, cool. How's it going, guys? Yay! All right, let's get this going with a little bit of energy. All right, so I'm Raouf Chebri. I'm a developer advocate at Neon. And today, yeah, we're going to talk about a bunch of stuff. But I wanted to start actually with a slide about me, just to tell you a little bit about what I do outside of work. If this works, doesn't matter. It does. Oh, I think I don't have control over this slide. Yeah, I do now. Cool. All right, we're starting really well. All right. So yeah, outside of talking about Neon, this is what I do. I like to cycle, and it's actually me suffering after an 18-hour bike ride, over 250 kilometers in the Swiss Alps. And yeah, in a nutshell, I'm somebody who likes to suffer. And this is why today I'm going to talk to you about riding pgvector. So, all right. So I talked about Neon. I said that I work for Neon. Yes? A little bit down? Or up? Louder?
Doesn't work at all.
It doesn't. Oh, it doesn't work? Okay.
Yes.
What about now? Better? Okay, cool. All right, so I'm trying also to be a little bit on time. So yeah, I mentioned that I work for Neon, and we have a cloud service. We actually love Postgres, and that's what we do. We have a Postgres offering in the cloud, and that's why I like to explore pgvector and talk a little bit about pgvector. And who are pgvector? No, sorry. Who loves Postgres here? Love Postgres? I think I know at least 2 people over there who need to raise their hands. Okay, who use Postgres, even if you don't love it? All right, most of you guys. Yeah, so we love Postgres. Obviously, we have a service that actually offers Postgres, but so do over 50% of the community. Here it's professional developers, about 45% of software engineers use Postgres. And yeah, it's the new hot thing. It's not that new, but it's hot right now. And I think there are many reasons to that. Well, the first reason is it's ecosystem of providers, right? Like you can have Postgres running on Google, and then you can, you can migrate to AWS and a bunch of other providers. And also, I think what makes Postgres really popular is the ecosystem of extensions. So Postgres is not just a relational database, but you can do geolocation with it, and you can also do vector search, and this is what we're going to talk about today. All right, yeah, but I promise you that using pgvector is actually simple. So what is pgvector? I mentioned it before, it's an extension. It's an extension for vector search. And nowadays, every database needs a vector search, right? So we spoke about Milvus, and there are open source, non-open source. There are databases that just incorporated vector search in their system, and there are other databases that only do vector search and do it really well. All right. So what is the problem that vector search is trying to solve? Well, it's quite simple. So it's trying to augment like the search capability and overcome the limitations that we have with keyword search. And I have an example right here. So here I have a job posting about a web developer. But the problem here is if you use any of the keywords that I have here in green, you wouldn't be able to find out about this job offering using keyword search. However, with semantic search, what do? You convert those keywords into vector embeddings, and then you calculate the distances between those vectors to find out about the sentences that are the closest to each other in meaning. So far, so good? Okay, cool. So from now on, it's only gonna get weirder. Just to let you know. So we're gonna talk about RAG. So RAG is another thing that we invented. It's a cool word, by the way. I love it. So you just throw some fancy and cool terms out there, and you sound very smart. But RAG stands for Retrieval Augmented Generation. And really what it is, and actually I would love to get your opinion about that. So for me, it's, as of now, it's a kind of a hack that we have with LLMs. So we basically we inject additional information to LLMs to steer them a little bit, to give us an information or to give us a response that we think is going to be right. So here I have an example. I asked ChatGPT what neon is, and obviously its first answer, it's about neon, the chemical element, and not neon, the company, which is totally normal. That's what 99.9% of the world's population would be asking about, right? But if I give it more information, I say, actually, neon is a Postgres offering. And so in this case, well, the answer is just going to be about neon, the managed service. So I just helped the LLM do that better. So and what RAG does for us is automate this entire process. And what we do, so this additional information is actually called context, and the whole point is to have that as a document in the database, and we can do search on it, and we can search using vector search. So the steps are quite easy. I have my application here. I turn my user query into an embedding, and then I do my vector search at the database level, and then I give my model additional information to give me a coherent answer. And the way it goes is you have a query, which is here represented in purple, and then you need to find out about like the vectors that are the closest to it, and that's what the vector search operation does. All right, and then so we said that those vectors correspond to a certain text. So the concatenation of those texts is called context in this case, and that's the information that you want to provide to your LLM. All right, so why would you use pgvector? Quite simple. Well, I like to talk about Postgres as being, the Swiss Army knife. Like, you can do so much with it. As I mentioned before, it's not just a relational database. You can add so many extensions, and you can really do whatever you want to do with it. So yeah, you would use pgvector because it's just Postgres. And there are some other misconceptions about pgvector, which is it doesn't do well at scale. But actually, well, define scale. We're not talking about 100 million, 200 million vectors. But if you have millions of vectors in your database, then actually pgvector provides with indexes. So you have AVA flat and you have HLSW indexes that actually can optimize for performance. We also have parallel index build now in pgvector. So when you build these indexes, they're it's quite a taxing operation that requires a lot of memory and CPU. But what you can do now is just give it as many CPUs as you have, and you can speed up that process. We also have the scalar quantization or half precision vectors. So basically, the vectors in pgvector are presented by 8-byte floats, but you can also just shove out half of that storage space by using half-vec type instead of a vector type. And you also have binary quantization. It's there. To be honest, I've tested it out. So it's not necessarily something that I would recommend using, but it's there at the moment. All right. So yeah, and as I mentioned before, it's operations that like everybody has studied SQL, so it's quite easy to get started and quite easy to create indexes. And here is just to show that actually when I have this is from a table that I have that has 1 million rows, and I just wanted to show that actually even here I have about 400 megabytes of I'm using 400 megabytes of storage. Creating those indexes actually can require a lot of memory as well. All right, so I don't know if I have time, but I wanted to show you. An application here to illustrate a little bit what RAG is about. And actually, let me show you some code here. I'm going to. All right. I hope you guys are not going to use my OpenAI API key. I'll trust you. And you can trust me that I'm going to be deleting it right after this presentation. All right. So, but you're also going to see my my Postgres database. Ta-da! Okay, all right. Here I just created a Postgres database. I'm going to copy the snippet. Oh my God, can I do it super quickly? 1, 2, 3, go. No, didn't work. All right. Run dev. And let me just refresh this. So as I mentioned, nope. Yes. So as I mentioned, RAG helps me to actually get information or create a coherent answer based on the information that the LLM maybe hasn't seen during training. And here is just a simple application, chat with PDF. And I'm just going to upload this, this document about mixture of agents. And I'm going to ask the question, of course, why do you fail? I'll blame. Say that again. Because I'm using bun. Because I haven't saved. Yeah.
Bun.
Oh, okay. All right. Nice. People are spotting things. Okay. Let's try again. Nope. This is what happens when you code live. That's why I like slides. All right. So, hey, it worked, right? If I go to my tables here. Ta-da! All right. So what are mixture of agents? Okay, let's cut the suspense here. We know that it works. So yeah, it just to illustrate that that's what RAG allows you to do is for example, this is one of the use cases where you can actually talk to your documents, and you can imagine like an application that has maybe thousands of users or tens of thousands of users. And this is why we talk a lot about scaling, vector search. All right, I think I'm actually quite on time this time. I'm usually always over time, but yeah, this is an overview of Neon's architecture. I'm not going to go there, but the reason why you saw me spinning up that Postgres database so quickly is because we separated storage and compute. But yeah, if you have more questions about that, we can talk about it later. Yeah, with that, thank you so much, everybody, and yes,
thank you, Raouf. We have a packed schedule, so I'm going to take one question. Does anyone have a question? If we have no questions, then I'm not going to take questions. Oh, yeah, there's one. Okay, I'm going to give you the mic, so we need it for recording.
So I have a small question about the implementation of RAG.
Mm-hmm.
When you run a query through your LLM,
Mm-hmm.
and I guess your database stores in each row the embedding, right?
Mm-hmm. Yes.
Do you compute each dot product like piece by piece?
Oh, that's a
because you can get a substantial speed up if you compute a batch right?
Sorry, if I got the question right,
Yeah.
when the documents are turned into,
No, when you query your rack, you can have the dot product with many rows at the same time, right?
the dot product of many rows at the same time. Yeah, you go through the database and you perform the operation. Yes.
Okay.
Row by row.
So that happens actually.
Oh yeah. So am I using an index in this example? Absolutely not. No, because I have only 30 rows, or I didn't see how much. Like So the
Because if it scales, and I guess that's the main issue, right?
correct.
Yeah.
Yeah, because I have just I don't have a lot of rows, so I don't need an index. But if I start having something like 200,000, 500,000, maybe a million, then maybe those operations of calculating all the distances between the vectors is going to be so big that I will need to use an index. And in this case, there are ways to make it faster.
Thank you very much. Thank you, Raouf.
All right, thanks.
Thank you. All right, we'll have a second speaker now, which is Nikolai from Google Cloud. She's coming now. Thank you.
Hello. Mic check. Okay, seems to be working. All right. Let's make this fun. I love how we are at the meetup called Unstructured Data, and the first presentation is about Postgres to a degree. And I also have Postgres, so we're starting really well. So let me figure this out very briefly. I'm going to go completely YOLO and share my whole screen, so corporate secrets and whatnot. Gonna make it easier if this works. Oh, and I forgot I need a microphone, because we're gonna have some dumb demos today, the way we love it. So, Infinity window check. So, this is the biggest presentation I've done this year. It has 6 slides. Last slide says, okay, thanks, bye, you will see. So yeah, very briefly about myself. I'm Nikolai, and that's enough. And today we are gonna talk about this. So basically, I mean, since we had some ChatGPT before, why not talk about Gemini? But I promise it's not gonna be very boring. Well, maybe to a degree. What are the caveats? What it can do in reality? And we're gonna have a lovely, nice demo that will probably fail 90% of the time, but this is how I roll. So yeah, without further ado, this was me, early 2024, most likely drunk, and I was saying that chatbots are lame, which I still think they are, but when you need to do something really concrete, and you know how to do it and what you want to achieve, they can actually become quite useful. And it started sort of a journey for me. So what you will see in my presentation today was kind of tailored for one of my customers. It's a very big gaming studio, and they were trying to create a fairly smart AI agent that could interact with users and could kind of connect to their backend and interact with the 3D rendering engine, could interact with their databases, could understand multiple languages, and all of that. So as you know, there are tons of products around this area. Like we have LLMs everywhere. All the startups are now like Gen AI and all that crap. But actually, if you want to see something built in a relatively short term and see it like being useful, it's not so easy. So, of course, I will be focusing on the Gemini because it's the one that I'm using. Well, to be honest, it's the one that I have for free because I work for Google. So the current state of it is actually quite nice. There are some caveats that we will cover, and I think they're important to know before you dive into developing with it and all the APIs. But it has a pretty substantial knowledge base. It can do very well summarization, and we internally use summarization in all of our tools for conversations, emails, and so on. So that's nothing new. Text content generation, this is the most common feature. Write me an essay for my university, something. It works well, then you need to add some personalization, then you get a good grade. Now, the multimodal part, it's becoming more and more, let's say, available to everybody, so you can just send the images and videos and try to understand the context of it, so it's also quite nice, and we will see some parts of that today. Long-form content analysis, whatever, visual information analysis, so you basically send a picture, it tells you, there is a cat on the photo, like you're blind. But anyway, it can do something a little bit more in-depth, but you cannot rely on it to do, for example, quality control for, I don't know, PCB production or assembly and so on. So caveats there too. Now the translations, and I put bananas because I was blown away when I was doing my demo. I just randomly, after some beers, started talking with it via voice in multiple languages, and it would just understand me seamlessly while I was like, my tongue was a little bit, it was working really well. So yeah, assistance and code analysis and code generation, this is for developers. Generally speaking, I tend to use Copilot and Gemini Code, whatever the name is right now. Most of them are okay to a degree, but still, I think they're very good for people with experience, so developers that know what they're doing, and not people that are starting from scratch and relying on them to generate code. Because code, generally speaking, is iffy at best, but it's very good for creating structs, creating database structures and from the beginning and so on, from start and whatnot. So yeah, this is what it can do. It's a fairly comprehensive suite of tools and features and so on. So yeah, let's start with that. Today's talk is focused on function calling, and probably most of you already heard of it, but what it does and what's useful, its usefulness is in that, LLMs, they're basically statistical models that just spit out the most probable next word in very layman terms. But what if you needed to actually go and fetch information? So it's kind of like RAG, which can be applied to this, but a little bit more programmatic. So basically the models are trained, like Gemini, like Mistral and some others, they're trained to understand that there exists a context outside of their knowledge base. And if I'm asking something that it doesn't know, instead of making it up, it will tell me back, call a function in your code. And this function can be get weather, fetch something from the database, draw a picture, whatever it is. And you define it. So whenever you instantiate your model, you have some parameters where you say, okay, I have these functions, call them when the user asks for X, Y, and Z. And this is basically what function calling is. So in this particular slide, I don't even remember what I put there. Yeah, something about the weather or extract data. I say, what's the weather in Berlin? LLM doesn't know. What it will do, it will come up with some bull crap. Instead of doing that, it will say, okay, code base, call get current weather. Then you invoke your method, it will call open weather API, get the data, fit it back into the model, and then it will reply in a very nice sentence saying, oh, the weather today in Berlin is raining cats and dogs or whatever. So yeah, that's kind of the thing that we will be focusing on today. Now, this is kind of a life cycle of function calling in Gemini, but it's extremely similar to all the other models. So you have your prompt, the prompt goes to the model then calls the functions. That could be REST APIs, databases, document repositories, whatever, custom management systems, and then just responds back. Extremely simple. There is really nothing complicated about it, and people tend to make it extremely sound like they're geniuses or something. It's pretty straightforward. And if you're actually interested to know how the models are trained on function calling, if I'm not mistaken, it's on Hugging Face. There are a couple of Mistral and Gemma models. Gemma from Google, the open source one, and Mistral is, I think it's a French company. They basically give you a data set that they use for training the model to understand what function calling is. There is some magic behind the scenes, but it's not super complicated to train your model as long as you have 50, 40, 90 GPUs laying at home. So yeah, I thought to myself, okay, this looks nice, it's magic, let's try to build something, must be easy. This is pre-agony stage, because in reality it's not very easy. So, the hiccups. The hiccups are, at least with Gemini and other models too, RAG, that you heard about before, for sure, and in previous talk, and function calling, today, both of them at the same time, doesn't work. It just says, sorry, cannot do that, or either one or another. And you say, okay, yeah, whatever. Let's try some function calling and audio or video input. Doesn't work. So you start to understand that you need something like frameworks, and what was the name of the most famous one that is people are using sorry? Yeah, that one, LangChain. Me being a bit of a masochist, I decided not to use that and implement everything myself, but basically the way it works, you instantiate 3 different models, which are exactly the same ones. One does audio and video inputs, one does function calling, and one does RAG. So let's take a look at hopefully functional demo, and this is where you will see probably everything crash and burn, but maybe not. So just to see how all of this comes together. All right. So this is, bear in mind, my CSS skills are amazing, so probably something is going to be misaligned at some point. But just to give you a little bit of context, this is like fairly straightforward chatbot that can understand text and can understand me talking to hopefully functional microphone because it fell from the stairs like 5 minutes ago. And it will be able to show you not only text output, but it will also be able to generate images by using Imagen 3 and Stable Diffusion. Hopefully, we'll see some 3D stuff on the screen with changing textures and yeah, some basic interaction. So for the RAG part, what is happening behind the scenes, before I dive into this, there is, this repository is public. I will share the link with you in the end. There are 2 files. I'm going to open them right now that I just, oh shit, this is Microsoft Word. Boy, oh boy. Apologies. So for the context of this demo, I created a chatbot that is trained, well, he knows about 2 imaginary games. Those games don't exist in real world. They're called Cloud Royale and Droid Shooter. Those are inspired names on some of the things from Google Play Store, but they don't exist. I created up a story, I wrote some FAQs, so just imaginary things to make some ground information. And they're in the public bucket, accessible via, well, as you can see, they're just in the Google public storage. This Microsoft Word is driving me crazy. And the RAG from Gemini basically injects this information into the model, and it will know what I'm talking about, what I'm asking about whenever the right questions come. So without further ado, let's just start with something simple, like, who are you? And excellent. 1 moment. You see, this was not the right link. Apologies. AI agents, there should be a link somewhere here. This is the one. Starting well. Okay. Hopefully it's big enough for everybody. Let's just see. Who are you? Okay. It should say that it's a super agent because how does it know it's a super agent? In the code, you have something called system instructions. And system instructions, oh, sorry, there is no line wrap. Anyway, it's basically a string that you give explaining what the model should know. So basically the grounding, nothing particularly special. It says that you're agent, it's your name, you can do this and that, and you can understand multiple languages. So I can try to do the same by voice, but I'm going to try in a different language. I don't know, like in Portuguese. Quem és? Okay, so roughly the same answer. So it kind of understood that. And let's say I want to ask it, what orders do I have in my database? The database in this particular case is LODB, which is Postgres from Google on steroids. So let's see, I'm going to ask it to do. Какие у меня игры в коллекции? Different language. Let's see if it understands. So it should spit out the games that I have in my collection right now. Okay, it's being a little bit stupid. So can you show it as a table? Internal server error. Great. Let me try again. It's the connectivity. Can you show it as a table? Hopefully it can. I have a quota limitation. Yeah, okay. So here we go. We have a table. Now, let's try something completely different that can be a little bit more impressive. So show me my character. If it doesn't give 500, okay, here we go. So let's imagine that this is like a 3D character from my game. Well, of course, this is just a Google logo because I suck at creating 3D characters. And it looks like this. I can actually ask it, can you change the colors of character 2 to something that resembles Google's colors? It's called character 2. Oh, it's not character 2, it's character B. Damn it. Okay, done. Okay, let's see if it did the table thingy. So let's change this to 1 and to 2. No, it did not because it failed. Okay. Let's try different language. Desculpa, chama-se character B. Curious now. No problem, I changed the name. The character name? What? No, I didn't want you to change the character name. Okay, let's see if it changed. No. No, you idiot. I want to apply the colors for character called character B. It's gonna like, oh, sorry, this was very... Okay, hey, it blocked me, nice. Okay. No, you idiot. It's character B that you need to change the colors for. Something like that. I understand. You want to change color B. My apologies. Is there anything else? No. Yes, please. What can I? Okay, you see, it's a little bit of a fight. So to be completely fair, what I did was the temperature setting for the model is very, let's say, playful. So it tries to improvise a little bit. Can you please change the colors of character B to colors of Google? I want it to work. I want you to see this in action because it's actually quite nice. So I will show you. Done. Okay, I hope. I'm probably going to mix up the colors anyway, but yay! Okay, it works. Wonderful. So, last but not least, can you change my profile picture that looks like an orange cat? I don't know, just something came to my mind. So what it will do right now, it will call a model for image generation. So in this particular demo, it's Stable Diffusion, but the one that is on GitHub is using Imagen 3. Stable Diffusion was trained on pixelated data from Doom, Wolfenstein, and whatnot. So this is why it looks so amazing. Yeah, I like this one. So basically, I'm going to show you now the, oh no, I will not be able to show you because it's not a local database. But all of this data is being saved in Postgres. The functions, the way that it works, there is no magic into it. So if you want to check it later, it's fairly straightforward. It's on GitHub. I will share the link. But the way that things are done, let's give it a try. Like I don't know, generate profile picture now. But let's see what we checked recently. So the user, yeah, okay. Get user game. So basically, it's just a simple query to Postgres. It gets the data, it maps it to a specific model, and then it generates an HTML table as an output, spits it back into Gemini. Gemini spits it back to us. Now, regarding all those caveats that I told you about in the beginning, that you cannot do all of these things at the same time, if you go later on into the code, you will see that there are three things here. Okay, let me just stop. Okay, init model, the initial one, which is the Gemini 1.5 Pro. It has something called a retail tool, which is a function calling, and it gets all the function declarations. So if you come here, it has the explanation about all the functions that I've been showing you until now. So what's the description? Basically, when it's triggered, what's the name inside my code base? So if I search for get user games, it's been registered, and here is the same query that just replies back. Then I have the second model. We have something called Gemini Flash. I only use it for audio interpretation because it's extremely fast and it understands all the languages. I don't give it any context. I'm just telling it, if you check the configuration file for the audio model, please transcribe the audio exactly as it is without making up the information. So what it means, whenever I talk to my microphone, I send the audio file to my backend. The backend sends it to Gemini 1.5 Flash. It just listens to it and gives back exactly the same text. I grab this text and then I send it again to Gemini 1.5 on Flash. And then it starts calling functions. How did I did the RAG part? The RAG part is a little bit tricky because I cannot have function calling and RAG and voice at the same time. So it becomes a little bit more ugly, but still fairly usable. So if we look very briefly into the, 1 second. Get game information, and I will show you now. So it's another function, and what it does, the get game information, it just goes into another model call and asks it to generate content. And the RAG model was instantiated as this. This meaning it creates instantiation of, so basically I pass it to the files from configuration, it creates a corpora in Google Cloud, and it knows basically what it is. So just let's give a simple query that the model without being grounded doesn't know. So something like, yeah, how do I assemble artifacts in Cloud Royale? It's a part of the PDF document. So let's see what it answers. So it should say something that is actually true to life. Let's see. Okay, basically it says to assemble artifacts, you need to find and activate assembly terminals. I have no idea. So Cloud Royale terminal. Okay, yeah, so here it is. Assemble and unleash. So basically, you have to activate special terminals. It went through the document, and it actually gave relevant information to the user based on the FAQ or whatever documents that were shared with it. So yeah, once again, you can embed all of this, but it's just a little bit not as straightforward as we would like to. I know why these limitations exist, and I know they're being worked on, so probably in the next iteration of Gemini releases and probably other models too, this will be taken behind the scenes, so you don't need to do all this circus in the code, but you can still make it more or less straightforward. And with long chains, for those who are using it, it's already possible. Most of these scenarios, except for embedding probably the like image generation models and whatnot. So yeah, in a nutshell, this is what we have. Now, from the presentation perspective, I don't have anything here. So the last thing that I wanted to show you, and this is hopefully going to work here. So I'm going to just run it locally just for the database container for you to have a brief look into how all of this is structured in the unstructured talk that we're having right now. So 8081. I don't have the credentials, of course, because it's a wrong browser. And I also don't have the credentials here, starting really well. It should be somewhere here. Okay, Google no reply. And pgadmin Postgres. Great, incorrect username and passwords. Spectacular. So, step number 2. Why isn't it working? I do not know, because probably this was a previous version. And this is, yeah, okay. Great. So let's fall back a little bit into, instead of seeing the really nice pgadmin, basically the database is extremely straightforward. You have in-game products, you have game replays, you have character personalization for colors, so what you have seen there. You have user orders, which is just purchases and so on. So it's super straightforward database that you would find in any backend, and the functions just call it to retrieve the data and show it to the user. So what these LLMs in a nutshell do, they are just a different type of front end that makes the interaction with the user extremely simple. It's multi-lang, it's very easily embeddable, and it talks not in a very robotic way because I can tell it to be, let's just, for the sake of fun, very briefly, I'm going to change one little thing here in my local configuration file, and I'm going to say, you answer as a pirate. Let's see if this works. This is a local one. I hope it doesn't crash. Okay, missed it. No, because, apologies, there should be something here to say to reply professionally. So it's getting a little bit into the, I wanted, you answer it with a pirate speak. Let's see. I don't know if this is, oh, yeah, okay, I don't think it's synchronizing, but let me try again. Let me just reset this, and then I will let you go to the next speaker. But I just want to show you how dynamic this can be. Probably will not work, but okay, it didn't work, of course, because local development. Yeah, apologies. Yeah, this was not supposed to run locally. I just wanted to show you, but I will not deploy it right now to production because it will take at least 5 to 7 minutes, so it's not worth it. Anyway, to close this off, back to the lovely presentation. I can, I think, take a couple of minutes.
Thank you very much. Do we have questions from anyone? I'm going to assume we'll have some questions, right? No questions? Please? Yes.
No need. If you're interested in seeing the code for the demo, that is actually working. It's on a temporary GitHub from my team, but it will be published on Google for Games GitHub eventually. But it's going to be the same code base.
Yeah. Just a small question about this Gemini Flash translation. In prompt engineering, you said it not to make up information. Is it really, does it make a difference, or?
Sometimes it does. So I noticed that it makes a difference when you're injecting RAG, basically additional files with grounding information. Like specifics about, in this case, was specific about a game asset, like how to generate something. And it would, at certain point, instead of calling a function to get this additional information, it would just make up stuff.
But that was just for voice to text translation?
No. It was for text.
okay.
No, for the voice. So there are multiple instructions. One for the flash, which is basically just say what. So transcribe what you heard. Period. That was for the main model, not to make up stuff.
Okay, good. Thanks.
And I know it sounds a little bit dumb, but unfortunately, we still sometimes have to put these kinds of strange sentences for. Instead of playing with like temperatures and K values and whatnot, just those sentences. Yeah.
Okay, thanks.
Cool, thank you. We're gonna have a very quick break so we can open the windows. So guys, can breathe in. Thank you. Next speaker is myself. So I have no one to introduce me. So I'm just gonna introduce myself. It's a bit awkward, but that's how we do. So I'm here to talk to you about vector search. And I'm taking a different angle than everyone is doing at the moment. So I'm not gonna talk to you about RAG and what you can do with RAG and everything. But I'm gonna explain and show you how we can do vector search at scale. I'm trying to open this bottle as well at the same time. And I managed. Let's go. Thank you. All right. So yes, you've probably seen me, the same slide before. But I'm Stefan. I'm a developer advocate at Milvus. And just to repeat, basically, I try to make a lot of events in Berlin. So I try to run a lot of meetups, hackathons, different things. So also, if you have an idea for like events and stuff you wanna partner with or anything, let me know and I'll be happy to do so. Let's go. So I work for Milvus, and I'm gonna give you a quick intro. So we are an open source vector database, as I said before. And we take everything from a pip install to then scaling to billions of vectors. So we have Milvus Lite, which is very easy, pip installed by Milvus. And then we have integration with like a lot of different players. So like, you can think of like LangChain that was mentioned before, Llama Index, and many more. And yeah, we have been here since 2017, actually. So we've been here for a while. And we have like a lot of features. We support, like dense and sparse embeddings, filtering, re-ranking, and different things that actually have a demo for you at the end. So as I said before, we're like well connected, as we say, in the LLM infra world. So we partner with like a lot of people. We also partner with Google. We directly partner with NVIDIA and Intel for like hardware specific vector search. So we support, for example, NVIDIA Akarioh, which is GPU vector search. And yeah, then we work, with like different partners. Some people always ask me like, what can you use a vector database for? What is it like only doing like some RAG or something? Have you been here around for like only 6 months? You have different use cases. Like you have obviously RAG, which is what everyone has been talking about for the last year. But you also have recommender system or like text search, audio search, video search, image search. I have some customers as well that are doing a molecular search. So they're actually creating proteins using generative AI, and then they search for similar proteins using Milvus. Then you can also do anomaly detection, and then also have multimodal search. So those are like the common use cases, I would say. You can also, of course, do it for like different things, but those are the common ones. And now we're just gonna go. We'll have an alarm, but don't worry. It's just because the alarm is very excited about my talk. So yeah, we'll have the introduction to vector database and vector search. So for the people that don't know, basically, why do we exist? Why do we do a thing? It's because traditional databases were built on exact search. So, like you were doing like a select star from your table or something, and you didn't have semantic search. And the alarm is gone. Yay. So basically that's why they were like built on that. And so there was a problem because then you can miss some context. And then you can be also confused by the semantic meaning or the user intent. So like, if I mean apple, do I mean the fruit or do I mean the company? So like, that's basically why we exist. Also, another reason, and that's actually the reason why our founder created the company is because a lot of people use structured data, but a lot of the data actually is unstructured. So it's also how can you deal with that? How can you deal with unstructured data? How can you make it happen? How can you search for it? It's apparently like 80% of the new data is supposed to be unstructured. So that's also why, we're like here. But then how do they work and how do we work? It's basically similar to search everywhere. So you get your data, you have your unstructured data, which is, like your images, your video documents. Then you transform them into vectors. Then you have your vector embeddings, which then you store directly in your vector database. Then you have your user, he's very happy. He's going to perform a query. Then you transform them again. You have those vectors. You put them into an embedding. Then you get those embeddings, and then you do similarities, semantic search. Sorry. So you're going to try to find the one that are the most semantically similar to you, and that's how it works. So if I tell you that, it sounds very easy. Like a lot of people also say, like, why do you need a vector database? Well, you can use NumPy and do it in 5 lines of code. There are different ways for that. Then you have a new alarm. Because it's a new slide, so it's very excited. So then I'm just going to tell you how do we do it at like billion scale. I'm going to explain to you how we do it. Then I have a demo which is unfortunately not at billion scale because it's very expensive. And there's no database, actually, there's no data set, sorry, that is available for billion plus scale. But I have a pretty big one. So the way Milvus works is that everything is separated. So like storage is separated, compute is separated. So if you need to like store a lot of data and then you have a lot of more and more data, but then you don't basically do any query, it's fine because you can just scale up the data part. If somehow you can have a lot of users suddenly, which are going to make a lot of queries, and then you can also scale up the query part and then just scale down the data part, for example. Well, those are like fully independent, sorry. So that's how it can scale up. Also, we fully separate streaming and historical data. So we have what is called, like all the new data that is coming is streamed directly into Kafka or Pulsar. And then this stays here into what we call segments. And then we have the historical data that is like in S3-like S3-like files, basically. So it can be GCS, it can be S3, it can be MinIO, or like different things like that. And yeah, as I said, so it's a fully distributed architecture. And then I'm just going to insist on the 3 different nodes. So we have the query node, which is here surrounded in red. So this one is here just for the query and also to query the new data that is coming. So it has access, you can see it has access directly to Kafka and Pulsar. So then for the new data that is coming, it's going to go through Kafka and then you can query it directly. But then it also has access to like all the data that you have in the back. So then if you have like historical data, that's basically what is going to happen, and then your query will make it happen, but then it's very independent to your data part and to your index part. So if you're building a new index, then those don't have an impact on each other. So that's basically how we can then make it possible to scale to billion plus. The data node, it's also connected to Kafka, but it's the one that, if you make like deletion and everything, it's like handling that. So then you don't have, to like compete for compute with the query node or the index part. And it also has access to then, like every historical data that you have. Then if you need an index, you don't always need one. Then you have the index node, which is what, it's like building the index itself. And this one, you can work it as like fully serverless, so you can scale it up and down. You actually sometimes don't need it if you don't have a lot of data. But that's basically because those components are fully dependent. It's how we can then scale up to like hundreds of billions. And I'm going to go a tiny bit more into details. So we have what is called shards, and those are like parts of the data node. And then we have 2 segments in there. We have the growing segment that you see in red. This one is all the fresh data that is coming. You have all the new data coming up. We put it there, and then once it reaches a threshold, then it goes into a sealed segment. This sealed segment is then pushed into S3, and then it stays there. And then like everything like that is always going into the growing segment, then we seal it, and then we put it into S3. And the part where, then if you like delete some data, what we can do is that we can just pick up a sealed segment, which is a subset of your data, and then delete that part, and then we don't have to rebuild the entire index. We can just rebuild the index of this specific segment, which is very important because, let's say you have 1 billion vectors. You don't want to rebuild the index all the time. You want to be able to handle updates. You want to be able to handle deletion without having, to like always rebuild your index. And yeah, basically I talked about those. So growing segments, those are in memory. We build a flat index directly on top of them. And then the sealed one are like the immutable ones, which are then, you build an index on top of. So it can be, like HNSW as we've seen before, but it can be GPU index. Where we support those when at one point, your index becomes so big, or you might not need all the data all the time in memory. So then we also have, on disk indexes. And yeah, I mentioned it before, but like how it works is that everything goes through the proxy. Then we have the log broker, where we divide everything. All the data is divided there. And then we send everything to the data node, and then we store everything in S3. So that's basically how everything works. And then when you make a query, what we do is like, we're going to query, like we're going to have the meta query basically. So that comes from the proxy. Then we're going to query all the query nodes at the same time. And then we're getting the top K of the query nodes and then regroup it again. It's the famous map reduce kind of thing. So that's also what we do basically. So then we can query everything at the same time and everything is parallelized. And yeah, that's how we can scale up. Some of the people that actually have billion plus are those people, those companies. So those are some of our customers, and I work with some of them where they have like 10 of billions of vectors. But now it was a lot of slides, but I have a demo to show. So let's see if it works. Hopefully it works. So full transparency for this demo, I am not going to use Milvus. I'm using hosted Milvus, which is on Zilliz. And the reason why is because my database is so big that it wouldn't fit in my memory. I need about 500 gigabytes of storage for my embeddings that are stored. So then I decided to just go in the cloud. So this demo is going to show you different things. I'm going to show you that vector search or vector database are not only about semantic search. So we're going to see like the different things we can do with it. I'm just going to show you quickly, and I need to do that. Yes, it works. So the data that I have is from Cohere. So Cohere embedded Wikipedia. So they embedded all the language of Wikipedia. And what I pushed in my data, I have embeddings for English, German, and French. So I have tens of millions of embeddings that are available. And I'm just going to set up a couple of things. I'm going to show you. So I only have one collection, which is the Cohere embeddings. And I'm defining the name. And then we can see some stats. So this one, I have about 33 millions embeddings there. So like 33 million vectors. And at first, I wanted to go bigger. But I don't know if you live in Berlin, but the internet is not very stable. And it's actually why. It's because then when I was pushing for my data, it crashed. My internet stopped working. And I did it, unfortunately, this morning, so that it was too late to add the rest. But you can imagine it's basically the same. I can describe the index that I used. So I'm going for an HNSW with a cosine metric. And in Milvus, we have like something that is called loaded, so the collection can be loaded or not. So I'm just making sure that the collection is loaded, because otherwise I can't query it. So okay, we're happy, it's loaded. I can describe the collection again, but I'm just saying like there's an auto ID. Okay, here are the different fields I have. So there's the auto ID, and then there's a text vector, which is dimension 1024. Then there's a title of the Wikipedia article, and then there's a text of the Wikipedia article as well. Because I don't know about you, but I don't speak vector embeddings. So then when I look for something, it's nice to actually have the text. For this one, because it's not that big actually, I need to go for one partition, one chart. But if you were to have hundreds of millions, 200 millions, usually it's better to like distribute everything. So I'm going to start with something which is called filtering. So I can just show you quickly. First, before that, I'm going to show you what the data looks like, because you might be confused if you don't know what it looks like. So it looks like that. We don't see the error on the right side. So it looks like that. So yeah, I have the ID, I have the vector, so the vector embeddings, I have the title, and then I have the text. That's how also I learned that Wikipedia has an article about April. It's just about everything that happened in April over history. And I saw it because I saw the title April, and then I got confused, and then it's just like, yeah, like a king was dead in April, whatever. So that's what the data looks like. So what I can do is I can do some filtering, I can be like, okay, just only give me the data when the title is like British Arab Commercial Bank. So we can do that. And we can see here, we actually only have like data, where the title is British Arab Commercial Bank. you know, and I actually didn't put any limits. So like the data should actually only be about that. So we can see, you know, the bank was founded in 1972. And yes, we only have data about that. So that's like something where you can show, you know, when you have a lot of data, usually what's very important is to do what we call metadata filtering, because you don't want to process all the data. You know, you need to save time and to save resources. Then I can also do like, you know, some other filtering, like just making sure the text is like something, you know, it has like the beginning or the end. And then this one I put a limit, but it's again, you see the same, where it's about calistasia. So yeah, it's like about flowering plants, and then you can see, you know, like you get those results. So far I haven't done any vector search, and then you can do the same. You know, you can do like not in whatever, and again I'm like, you know, searching over 30 million documents, and you can see it's actually quite fast. So then here it's about the Commonwealth Sky Ranger. So yeah, but now where the magic happens is that we have Cohere that is working with Milvus. So I'm going to use, you know, the same embedding models that was used to actually embed Wikipedia. And I'm just going to ask, who founded Wikipedia? You can see, you know, like just the beginning of our embeddings. So that's what it looks like. And that's how we do then the vector search later. So I can just quickly do the search. We do it here. I'm just passing the embedded query, giving the collection name. You know, I just want the text as an output, and I only want 3 results. So then, okay, we can see we have Larry Sanger and Jimmy Wales are the one that started Wikipedia. And then you can see, you know, like you have the start, you do a vector search, and then you have your results. You can see the distance as well, which is the cosine similarity. And yeah, you can learn more about Wikipedia if you want. I can also, then I'm just going to do that, which is only retrieving the lines with the distance, because in the end, I'm also using Ollama. So I'm using Ollama with Llama 3 on my laptop. And so then I'm going to give those lines and those distances to my LLM. So then it can, like, you know, we can actually do some RAG. So yes, we have the same results. You know, Larry Sanger and Jimmy Wales are the ones that started Wikipedia. And yes, I'm just going to, so I'm using RAG without Llama Index or LangChain or any frameworks. So I have to like actually build the context myself and everything. So I have the same one who created Wikipedia. And then, you know, you have the system prompt that you've probably seen, your AI assistant, you know, please find answers. And then you have the user prompt, which is what you're going to give, you know, to your LLM. So you have the context, which is what I gave before. And then you have the question. So we're going to build that. And here, I'm going to call Ollama. It's localhost. If you're wondering why I'm importing OpenAI, it's because Ollama is fully compatible with OpenAI SDK. So then it's very handy. I can just use it like that. And here, we're going to try and see who created Wikipedia, and then we're going to have it as a very nice answer, because the LLM, they always like to make very nice answers. And then that's the time when it takes a bit of time, you know? Yes. So then the LLM is like, according to the provided context, Larry Sanger and Jimmy Wales are the one who started Wikipedia. And that's basically, just wanted to give you an intro of like how Milvus can build at scale, you know, how we can actually do it, how we can distribute everything, and then how we can then, you know, do the RAG. There's used to be the cool kid in town. Now it's all about agents, but agents usually also use RAG. So I'm just going to release my collection because otherwise I'm paying for the collection that is running. And that's kind of it. Thank you everyone for your attention. You can give us a star on GitHub. You can add me on LinkedIn. And that's it. Thank you. Do we have any questions? Otherwise, I will introduce our next speaker. Hi, there's one. Where? Here?
Thanks, Stefan, for the talk. So we have on the one hand classical search engines coming from text who add vector vector query functionality, and then we have native vector databases like I guess Milvus, and then we have classical SQL databases that also add vector search capabilities. So is it all converging now to one and the same set of features, and which solutions are currently performing best when it comes to information retrieval?
That's a good question. I think it also depends on the use case. So I'm going to be asked to be told if I'm wrong. For the one from Google, for example, I know it's like extremely fast on some very specific use cases. Maybe you can have a quick chat about that. But and then for the rest, like I've been asked, for example, about Mongo or about different things. Usually the way others are doing is that they add a plugin or something, like a vector search plugin. So that usually is nice because you just add HLSW, but then you might not have some capabilities, updating the index or, delete, updating the data without recreating the index or deleting the data without recreating the whole index. So those are features that usually other companies don't have. And then I think where there's a big difference is once you reach scale, at one point, once you reach like more than 10 million, 100 millions of vectors, then it's where you usually struggle. And then you might, actually need something that is really dedicated, that is made for that. Cool. Okay. So yeah, thank you. There's someone there. Okay, it's perfect because I actually need to call my next speaker, which is Zoe, and then she needs to go there. There. Oh no, sorry, I was confused in my notes. Sorry. Oh my God. Yes.
Connected to the meet.
What's
in the meet.
I'm sorry if you covered it and I missed it. Do you use anything like this locality sensitive hashing technique to speed up the retrieval of the nearest?
So we can, yes, we can in some cases. Yeah, it's used. Like I didn't use it here, but yes. Yes, exactly. I don't always use it. It's like in some specific cases you need to use it, but like for this one, no need to because it's still not that big. Thank you. Sorry, it's Oleg from Docker that is coming. It's fun when you host and talk and organize the meetup.
Permissions.
Share screen.
Awesome. Nice.
Thank you.
Thank you.
You want this one?
Yes, maybe not. Hi, my name is Oleg. Hi, how are you? Okay, so you can see my slides. I have the power. This is all perfect. Right, before we start, this is because I'm a developer advocate, so I need the photo. If you don't want to be published on the internet, look away for a second. But other than that, smile, say something nice. 1, 2, 3, JavaScript. Very good. Right, so everyone was showing lots of slides here, so I got peer pressured into making slides as well. This is my slide. Hi, I work at Docker on the DevRel team. My main areas of interest are test containers, developer productivity, and AI recently. So here I'm going to talk about how you can use some of the Docker tools and how some of the open source libraries, namely test containers, so you can get more of the productivity from using AI components within your applications in your normal developer workflows. How many of you are more on the developer side of things, right? On the normal developers, not like AI researchers or not like. Okay, most of you, perfect, very, very good. Well, sort of 9 to 5-ish. No, like we've done development before ChatGPT was a thing, right? Before ChatGPT, were you a developer or were you a machine learning engineer? Actually, I don't know who asked that question. I'm looking at you, but it might not be. Right, so very good. Also, we're going to look at some code. So I'm going to show everything in Java. Don't get scared. It's a programming language. Some people feel strongly about it in different ways, but you can also do all that I'm showing in other languages that are more close to your hearts. Right, so if you don't know, test containers, it's a collection of open source libraries, and they give you programmatic API to do things with containers. Right, so containers are, of course, one of the core primitives for the current sort of DevOps practices. We package things in containers. We run things in containers. We do that in production. We do that everywhere. But also we can do that in development, which is how Docker comes in as a dev tooling company producing tools working with containers. So test containers are open source libraries. And you can, everything you do with containers normally by, say, running a container with Docker run, or configuring container to have exposed ports, or running commands in containers, you can do that programmatically from your code. There are implementations in different languages, and it's super, super convenient because once it's in the code, what you can do, you can put it in your actual files, right, in your project, and it becomes a part of your project. So what it can do, your application can create the environment for itself by running necessary service dependencies. For example, it can run like your database when it needs a database, if it's not provided. You don't use that in production because in production you normally have a database, but in development, you can create an ephemeral one running in a container. And it's super, super useful because you can do this. Your application tests can do this. So they can always create a new repeatable environment. So you can run the same way on everyone's machine. So everyone runs the same test. Your CI can run the same test. It's perfect. It's very glorious because you get environment parity, right? And you don't have to do anything because it's all in your code. So somebody smarter than you on the team already wrote that, and you're just using it. Or if you're the smartest one on the team, so you should write it down and introduce it to your projects. And then everyone will be like, yeah, you are the smartest one on the team. Right, so there was a low-level API that tells you, oh, run this Docker image, expose those ports, run those commands, wait for this log line to appear for the software to be running. It's all very convenient, but it's also kind of sort of low level. Normally, when you run technologies, you don't want to think about how to run it in a container. How many of you know how to run Milvus in a container? 3 people. Not, you have a lot of work to do. So this is where, but this is not, it's not a new thing, right? Like nobody knows how to run particular technologies. They've never actually put effort into learning how to run them in containers. So this is where test containers being in the code comes into play, because being in the code, it's capable of abstractions naturally. So what we have an ecosystem of modules, which are predefined abstractions to run certain things out of the box. So, for example, you can run like normal relational databases or vector databases. And if I click here on my Milvus, what do I see? I need to import like a library into my code, and then I just created Milvus container in one line in my code. And this is what I have exactly here, right? What I have here. Right, so here's my piece of code here. I added test containers libraries, and this is the code that I will run. And this is just my normal Java code. What I do, I use the Milvus container definition, and it comes from a library. You can see that it comes from my bytecode files in the library. And I can just run it. I have the API to control the life cycle, and I would put that in my tests or in my application lifecycle. Before it starts, it can create a Milvus for me. So, and there I just connect and print the version of that. So I can run this very normally. I don't need to have anything installed in my machine. I only need to have access to Docker environment, because that's where the containers will be run, right? And they are just running normally as like this. Just we run, we determine the Docker environment we are connected to. I'm currently using the cloud backend for this. We are pulling the images if they need to be pulled. We create the containers, and then we can connect to that Milvus instance from our code right here. So if I would put it in my tests will never break because the environment wasn't ready, right? Because it creates an independent, isolated environment for my application by itself. And it will never get out of sync with my application needs because it's right in my application code. So it's perfect. How does it get us closer to working with AI components, right? It's not just, you can imagine how to run it with a database or with Kafka or with Elasticsearch, and it's already very useful. But now we are sprinkling AI into this, right? What we would like to do, we would like to be able to run random LLMs on our machine or in our environments in the same isolated, closed-loop, repeatable fashion. So this is where test containers modules come to help once again. So what we have here, we have the definition for an Llama container. Llama is, of course, a technology that allows you to run different models locally on your machine, which is also very, very good. You can package that in a Docker container and run a Llama within a Docker container, which is what we're doing here. So what I can do at any point of time in my code, I can just say a Llama container, run with whatever open source models Llama supports. For example, say a Llama pool Gemma or Llama 3, Llama 2, or smaller models, and run it, and it will be in a container on my machine. So the same way I just created the Milvus database, I can do a Llama. So, and here I have an example of that. So here's an Llama vision model example. It's a test because it's easy to write things in tests because there is a certain life cycle. And also, not enough people in AI industry are talking about normal DevOps practices. You cannot ship software without tests. This is not like, you cannot. Because you will leave and somebody else will look at your broken code and will be like, why is this not working? So you need tests. So everyone should write more tests. So in that spirit, I put all of this in the tests. And I have a bunch of pictures here, right? So some of them is the cat that we saw. So what this code does here, right? I instantiate my Llama container, and I give it the Docker image name for what I wanted to run. I started, and also I do a little bit of a hack. So here, if I don't have the container with the model already available, available on my system, I will actually commit that image programmatically. So I will try to run a Llama, I will pull a model called Moondream into that, and then it will actually commit that image. So next time I run this, I don't need to pull the model again and again and again, right? I want to programmatically kind of sort of checkpoint that thing. So I did that with this little idiom here. And then after that, I just use that Llama and ask for endpoint programmatically, and I can send queries to this programmatically as well, which means I can use this in my applications to build in AI components into kind of sort of my application environment where it needs to run in a way that is similar to how we work with databases or any other external dependencies, making AI stuff just a normal part of my DevOps process where I know how to work with things, right? So when I run this, the same thing happens that happened with Milvus, right? We find the Docker environment, we create the container, we are starting the Llama Moondream container. I already pre-pulled them into this particular Docker environment, so I have the images available. So I just need to start them. And Llama will load that model, Moondream model, by using the pool functionality and give me the answer that the particular image that we were asking about was a whale swimming in the ocean. So it was this one. This whale swimming in an ocean. There is no ocean, but you cannot ask LLM to be very precise, right? So now this is just a part of the things. This is like what models you can run with a Llama that they have support for. So how do we actually distribute models? This is very interesting. So this is Hugging Face. How many of you know Hugging Face? This is the home for models, right? Models here in Hugging Face sense, those are Git repositories. So there are files. And this is kind of sort of a very convenient to distribute large files, but it's also not the most convenient way to work with things as a developer, because probably you want better and easier to use abstractions. So this is exactly what you can do here with the combination of the tools that we saw before. Besides just having being able to install into Llama any models that Llama supports, you can also install any models that are available in the gguf format, which is sort of currently the most standard format to distribute the format for the weights of the model, kind of sort of the essence of what the model is. And then what we do here, and Llama knows how to read that. So what we can do, we can specify in the code certain configuration, how to deal with particular models, which is here, for example, is the Lava 5.3 mini gguf based, and we can create the abstraction to run those, and then we can use it the same way. So you need to specify some particular file for massaging how you prompt things and some other things for the model. But once you have this in the code, that's the benefit of the code. You never need to do this again. Right? You put it in a file, you call it my Llama container with Hugging Face model for Llama 5.3 something, right? And you never look under the hood of that ever again. So here what is happening exactly the same thing is we load this model into the Llama container, we define it all programmatically in the code, and we run this. And you can do that with, I think there are more than 20,000 models here on Hugging Face for the GGUF, which is a pretty big collection of models for you to choose from. So if you want to augment your application with some AI things, maybe there is an open source model that fits your needs. Maybe there is a model that is trained on the credit card transaction logs and can predict the next faulty one or fraudulent one, or at least maybe flag it for you, right? Or maybe your application needs to look at pictures and determine whether there is a frog in the picture. You might go for the big guns. You might like go to ChatGPT for that, right? But that is a little bit like nailing nails down with a microscope. ChatGPT can do so much more. It's a fully generic model that burns however many GPUs for every request. Maybe there's a smaller model that you can run locally through a Llama in this thing. Right, so you're doing this, and I have 2 more minutes for which I wanted to show you another thing, which is also sort of possible, and it's a very natural step from being able to run those models locally, like I showed you in development, is also you need to test these things, right? How do you test components of your applications which are non-deterministic? And in addition to that, the interface to those components are text, which is, from a developer point of view, that is the stupidest API surface anyone have invented, right? Because it's, well, how do you work with text when the input is text and output is text? There is no form, it's impossible. So what you need to do, and it's also like random text, which can change over time. So what we think could be a useful trick to do this is to include another AI into the test practice. So when my application is like this, for example, this is a simple Spring application, and it has one endpoint here, which I feed information about test containers, and it gives me back some information about test containers. And it's very kind of sort of generically dumb because the online models are not very good at particular details about sort of smaller open source projects, and we just feed it a little bit of data, but it works. So in the test here, and you can see this example later, right? What I do, and what I think is a valuable way to organize your tests. The same way I normally have just, for example, the question and execute the production code to get the output, right? So in this example, I ask which test containers modules are available, and then I actually send that question to my application. Instead of just asserting the answer, because I cannot, because it's a randomly generated natural language coming back. What I do, I provide a reference that explains what the answer should be, right? And in this case, it should include, for example, those modules because they were in my rack. And in my evaluation method, what I do, I create another chat model, right? And I configure my chat model saying that, ooh, you know what? You are a validator. You are not just a thing, but you are a validator, and you will need to respond to the things in a way that I have configured. And then I feed that into my application. I feed all the parameters, my whole prompt. I feed the question, I feed the answer, and I feed the reference to assess whether the answer is kind of sort of meaningful or not. And I can run this. And it runs pretty decently. And it all currently sort of runs with my local setup here with the fixed versions of everything. It will take, I think, a little bit of time, but I can show you how test containers configuration is enabled for this while it runs, right? I have my Llama container that it provides my kind of sort of the brains of this operation, both for running the application, but also running the validator agent. And I'm using the quadrant for my rack through which I feed some of the test containers data back into my application.
Can you change your text file?
Can I change my text files? Thank you very much. Well, this is very good. Never trust a test that you haven't seen failing. If a test never failed, probably doesn't assert anything at all. So now we will run this again, and hopefully it will be green. So I'm out of time. So whether this particular test is green or not, I think the important part to remember that there are tools that can help you bring AI components into the development in the inner loop, normally as you would work with any other technologies. There are tools to programmatically create environment for applications for local usage or for the tests. And you can also, you should test more, whether you're doing AI or not. I think this is one takeaway. Test more. Through better tests, we'll get better software, and through better software, we'll get better world. Very profound. Thank you very much.
Thank you very much for the presentation. Do we have a question from someone? No? But yeah, don't forget to test. We used to have a saying, which is garbage in, garbage out. So that's a way of saying it. Thank you very much for the presentation again. And now I have Zoe from InfluxDB. So she's just going to set up, and then we should be fine. Cool. All right. Thank you, everyone. You may come back with a quick drink in your hand. We are going to start very, very soon again.
There you are. You came back. I don't blame you.
All right. So yes, now we have Zoe from Influx Data or InfluxDB, and the stage is yours now. So go for it.
Thank you so much. Audio sounds good? Yeah, seems fine. All right. So we're going to go ahead, and I'm going to be talking about improving analytics with time series and vector databases. So we're going to be comboing. So really quick, my name is Zoe Steinkamp. Everyone in the US just goes by Steinkamp, as you can tell by my accent. That's where I hail from. I'm from Denver, Colorado, which is basically smack dab in the middle of the country. I'm a developer advocate for Influx Data. I help a lot of not only customers on our open source, but also on our paid product. We are the kind of database where we work with lots of partners outside of ourselves. We have a lot of analytics tooling, a lot of other DBs, because as I'm going to explain, a vector database almost never runs as the only database. That would be a little strange, honestly. And this is my LinkedIn, since I know a lot of people might not have time for questions because we're kind of running quick, so we can do networking after. So when do you normally use time series databases? So I already kind of mentioned this, but you hardly ever run them alone. It's not like a SQL database that holds all your data for the first couple years of your company. It grows and it's fine, and it holds very good stuff. Time series databases tend to be very specific use cases. So the most common is going to be IoT. So our biggest customers tend to be within the industrial IoT space. So I don't know how many people here have ever walked on a factory floor, but when you walk on those floors, there are thousands of machines normally, many, many, many. And even something as simple as an arm picking up a pallet to stack it has hundreds of IoT devices up that arm, because it needs to know things like pressure and temperature and other sensors that basically give you health metrics. This is also extrapolated into things like green tech. When you have when you are collecting wind turbines out in like the ocean and stuff like that, they all have hundreds and millions of sensors of them on them as well. This data tends to be high write throughput. An IoT device tends to give you data roughly every nanosecond. In a day, it can become billions of data points very easily. And go ahead and extrapolate that out, like I said, to hundreds or thousands of IoT devices, and you deal with a very high amount. You need to be able to efficiently query over time ranges. So this is also something very unique that we deal with, is that our customer's first question is almost always time-based. It's what was the average pressure in the past 5 minutes on device 60? What about the average temperature over 20 devices over the past 2 days? Those are almost always, though, going to be time-based queries, where the first thing you think about is a time. It's not an ID. Although I'm mentioning IDs, it cannot be ID-based. You could just be more extrapolative and just say something like, what's the average temperature over all of my data sets, for example. And so obviously scalability and performance also comes in the fact that we tend to deal with real time. So that means that people send their data in and then they pretty much request it right back out, maybe like a minute later, because these are, again, real-time scenarios. Somebody's on a factory floor. They are not staring at 1,000 devices with their human eyes and determining what's wrong. That's not how this works. there is a machine, it's normally some analytics tooling. In the future, it will be more like machine learning without a doubt. And they're basically already telling them like, hey, this is like machine 20, you know, like 2 miles down the factory floor is acting strange. Like I can literally tell off the metrics right away that this is not quite right. I'm going to go ahead and shut stuff down so things don't get out of control and people don't get hurt. So you have your real time, and then you also have your like day or two later. For every single factory, there's probably 20 others that do something very similar. And their, you know, parent companies, they go ahead and send that data up to something like a cloud, and then they can extrapolate. If you have something that makes, for example, we recently worked with a customer that make toilet paper. You think that's, you know, relatively straightforward. They had about 200 different machines to make the toilet paper. Even this machine that's as simple as stamping it, just putting the little stamp on it so it looks nice when it comes to your house. And all of those have tons of things where they were like, this machine has actually malfunctioned in the past, and it pretty much almost chopped off someone's finger. It's not, you know, it's not easy stuff to deal with. And they take that kind of analytics and extrapolate it over their 20 different factories because they make toilet paper for like multiple different countries, basically. So these are kind of the things that we tend to deal with, which again means that we're not the only database that people tend to use. They use other DBs for storing other types of data, but this is for your IoT, your time series, your more time sensitive, as we like to say. So, for example, when it comes to vector databases, we have an example project, which we actually built long before we were going to come to this meetup, which basically involves time series, InfluxDB Cloud time series data, sensor data. For example, in this one, it's traffic data. So imagine you are in a city, you have a road or many, many roads. With this one, we were imagining, you know, hundreds of roads, a city like Berlin. And you have those sensor strips kind of on the ground, basically, and they monitor things like vehicle speed, how many vehicles are on the road, what kind of vehicles, is it a car, a human, a scooter, a bike, what have you. And basically from those sensor data, we imagine that some of it would go into things like influx, and you would get things like a vehicle count and average speed. And that's data that you could use for many days, not just for like real-time monitoring. But then you go ahead and add things like cameras, which I know some people are contentious about the idea of cameras watching their cities and watching their traffic, but you know, let's extrapolate from that. And just imagine you do have a camera that was watching, and it could detect things with this data set by basically feeding. So basically what it would do is it would take the images, it would recognize things within them that it can vectorize, things like the cars, the colors, what's happening in this scene. You know, you can now train these models to recognize things like construction or accidents. And what does the accident involve? Is it, you know, a car just kind of hit another car? Is it like a car is flipped over, there's people crawling around? Like, what are we dealing with here, basically? And by vectorizing this kind of data within Milvus, we can actually have that anomaly detection go off. So for example, in our imagination of a smart city of the future, you wouldn't even need to call 911 when there's an accident, because the cameras would be alerting. They would notice things are off. They would notice things like, why did all the vehicle speeds go to 0 all of a sudden? Why is the image, you know, the vectorization images that we're getting, why is it saying that there's like people roaming around where they normally should not be? Why is there a car that's not upright, or a car that has a lot of front end damage? And it can go ahead and alert appropriate authorities. Now, obviously, you know, this is a project, it's a demo project. So, you know, we're extrapolating out and we're imagining a bright future. This could obviously go in a very different direction, but we're going to look on the bright side of things. So basically, and on the next slide, I'll actually have the QR code so you can go check this out. We have a nice, well-written blog that kind of goes into all the in-depth on this. But what we're doing is we're creating fake data because we chose the easy path. We chose the easy path. We actually tried to get this data from the city of New York, but unshockingly, they don't give it to anybody. So they weren't keen on us either. So we've created fake data that basically had things like start and end time, and specifically vehicle count, as well as average speed. And then we fed it basically fake images. My coworker was kind enough to basically go out into a street near her and just take a lot of images of that street throughout the day. And I think she did it for about a week, basically. And apparently that street was great for also accidents. So she also got a few photos of accidents as well. I think she lived in just the ideal location, basically, to get these photos. And she basically fed it into the vector database. She vectorized the time series data as well, so it could feed and learn off of that as well. And then she was able to get it to start mentioning anomaly detections. Now, one thing she did have to do, since we had randomized data, she had to normalize it as well. So basically with normalization, that's just making sure there's not too much deviation in the data. So basically, we don't have a ton of cars going at like 10 miles per hour randomly and 60 miles per hour randomly. Like everything kind of has to be more natural, you could say. There's a natural flow to most things, especially traffic. You know, at 5 p.m. it goes for a crawl at 5 miles per hour, or 50 kilometers. Sorry, guys, I'm talking the wrong metric here, but you know, you get the gist. But yeah, so this is that project, and it explains how to basically vectorize your time series data. It talks about hooking up that data and sending it into Milvus and vectorizing it. And I'm afraid I don't remember the name of the vectorization that we used. It's a very specific, what's the word here? I'm lost for words on this, but basically it's a very specific way to vectorize time series data because it's a unique kind of data set, and everything can be vectorized slightly differently, including things like images and such. So the blog is going to be the better place to find that kind of information. This is also just some more resources as well. Things like we have blogs, documentation, our community where you can always ask lots of questions, including stuff, you know, more time series based and also time series and vector based. Because like I said, we also work alongside many other technologies. But yeah, that is the end of my talk. I was told I was doing a lightning, so lightning
Fantastic.
it is.
Thank you very much. Do we have any questions from anyone? No? No questions? Yes, do we have one?
Oh. Also, when you run it, you'll see this notebook, this Jupyter notebook that will go through everything and explain how to do it. I would do it, but I did agree, like I said, lightning. So.
Thank you for the presentation. Just a quick question. So did you get any good results from using similarity? I'm here.
Sorry.
Yeah. Can I not use the microphone? It's quite annoying.
I mean, it's better for recording. And otherwise people don't hear you if you're not loud enough.
Okay. Did you get any interesting results from actually using similarity search for the time series segment itself?
So yes and no. So the good thing is that it actually was getting kind of decent as we fed it specifically more images. The time series data was more like a, what's the word? Like fluff, I guess you could say. Like it was helpful for it, but the more images we took, especially of this specific street, since we were trying to target something like that for the similarity search in particular, it was actually getting better at recognizing accidents. To be fair, it sucked at recognizing anything else because we had no construction or no greater extrapolation. It was very, you could say niche. It was very narrow. But yes, we were able to ask it things like we would send it fake data that basically made it look like all the cars had stopped running. And then we also inlaid basically an image for it to see no cars moving, like they were at a stoplight or something. And it was actually starting to recognize things and starting to come back. I will admit it was not perfect. It definitely was, but because the data was random for the time series section of it, it was a little bit confused. We almost had to manipulate a lot of stuff.
That makes sense, actually. That's what I expected.
But I think we proved the point that at a bigger scale and with more data, we definitely think it could work.
Right. My second question is, so there was some talks about time series GPTs and mixing them up together. Did you guys have any interesting use case of that? Maybe even the RAG with time series? That would be really interesting to hear about.
I think we do, but I don't think I can talk about them right now, if that makes sense. We have a customer who's doing it, and I don't think I can mention their story. I think I'm under a clause on that. But the answer is yes, and we want to extrapolate this demo to start doing that.
Thank you very much. Thank you. All right. We have our next and final speaker now. We have Samir from Gatling. I'll let him set up quickly. But, you know, we had Docker talking about like actually testing things. Now we're going to have someone that is about load testing your LLM to make sure they can actually scale up. And you can just talk in this.
Oh, yeah.
I mean,
if you walk over there, just take this one up.
It would just be.
So hello everybody. So I will be like the last talk. So I will be try to be pretty fast for you to. It's like 9 p.m. typically. So I will talk about how to load test your LLM API using Gatling. So typically, what is load testing? So typically, load testing is you have your website. So it's part of performance testing. You have a website, your API, and you will try to send user to your API or to your website and see, like, if you send 1 million user, do your website or API crash or not? And typically it's really important because you have some websites like, for example, Amazon or big e-commerce websites. If they crash, they lose like millions of money, for example. And also right now, like if your website take 3 seconds or 4 seconds to load, you will lose like 99% of your clients. So typically in real life, it's the metro at Paris. This is every day when people are going out of work, typically. Also, it will be like bigger, like a lot of people, because we'll have like Olympic game at Paris. And you have like 3 ways of doing load testing. Typically, you have capacity test, which is typically only like you have 5 users at the beginning, after you have 10, after 1 minute, etc. You have stress test. Typically, your LLM or your company going into the TV, and you have 1 million users coming at one time. And after soak test is capacity test, but it takes like more than 1 week or 2 weeks to see if you have problems. So typically, to do the load test is typically coding. So it's SDK in JavaScript, TypeScript, also Java, and etc. If you don't really like programming, we also have like a recorder. Typically, the recorder, you go on your browser directly, and the recorder will generate for you the Gatling script. And also, we have a no-code interface. Typically, you just put your URL saying what type of request, and we generate the code for you. So typically for AI, you have 2 ways of getting the answer. You have the typical way of just like the API compute all the answer and send it back to you. Or you have also server-sent event, which is typically what ChatGPT does on the dashboard. So when you ask a question with a ChatGPT, you see the answer directly and it still compute. So this is permitted to server-sent event. And all LLM typically using it. You have OpenAI with ChatGPT, you have Anthropic, you have Mistral, and a lot of other LLM like Llama 2 or Llama 3, for example. And a small example is without SSE. So I just ask what is Gemini in 1 sentence. It will take like 5 or 6 seconds. And with SSE, you will directly like getting all the data. So it's small part of the answer, but you directly can already display it to your customers. And now it's like a small demo. I hope nothing will break. But typically, I will just zoom in. So typically what I do here is typically putting my LLM API on Coeb, which is a platform. You can host everything. You can host Olama directly. You have multiple people of Coeb here. Just after, I'm connecting directly to my LLM, thanks to the API, and I send a prompt, typically what is Gemma2 in 1 sentence. The thing which is pretty easy to use SSE is you only need to add stream true, and you were already using it SSE. And the thing with SSE is they send you a message to say that it's the end of the transmission. So typically it's data done to know that it's finished, like the answer is finished. So typically what we do is going into the loop, checking everything, checking every message, and when the message ends, we exit the loop. And typically to do it, we just need to do Gatling. And after hit, so Gatling will compile all the code, and after like create the report. So I will not wait for the simulation to finish because I don't have time. So I have already the report here. So thanks to Gatling, we see that for our LLM, we have good response time range, but also pretty bad because we have it takes like 1.2 seconds only for the answer. You can also check into details. So for example, if you have like your API with multiple endpoints, for example, 1 for your project, 1 for your chatbot, and 1 for other, you can directly go into details and see which endpoints have the best response time or not. Also, we have like Gatling Enterprise, which is the SaaS project, because when you have an LLM, like for example, ChatGPT, you don't only want to test it locally on your computer. You want to use like load generator from North California, Paris, Berlin, etc. So Gatling Enterprise needs you to do it, so to generate people from everything and everybody on the world. And also you have like more detailed reports. And you have also an integration with Google Cloud if you want to link Google Cloud with Gatling. Now, so also, if you want to support us, we have like a community forum, which is community.gatling.io. Typically, will be me or the CTO will answer your question. Just please don't take screenshot of your code. Just post your code on the forum. Also, you can start directly the GitHub because the core of the project is open source. I will not give you, you don't need to start to win a t-shirt. You already have t-shirt just at the table. And also you can test directly Gatling Enterprise. You have a free share directly. So thanks. Also, I made a blog post about this. If you want to check it on the QR code, we have a lot of information. You will have my email, my LinkedIn, also the GitHub for this demonstration. And if you have any question, I can answer you now or just after.
Thank you. Do we have any questions from anyone? No questions? No question asked. Well, thank you very much. Thank you. I'm just going to take over quickly, and then I'll let you people be free if you want to network, if you want to have a chat with everyone, or if you have anything you want to talk about to me directly, you can as well. I mentioned quickly, we have a whole wheel for people if you want to check. So look. So I picked all the people that left us a star. So then I'm gonna click to spin to see who won it. I have a lot of swag, so then I can do multiple spins. And I'm just gonna see who is data speculant. Maybe they left. We can't even clap. Who's data speculant? Not here anymore. Well, it's fine. We can do another one. I hope some people are still here. And otherwise, yes, we have some t-shirt from Gatling, from Neon as well, here on the side there, next to the door. We also should have some stickers that are on the way out. We have stickers from different companies. Koyab is here. We have Docker. We have Neon. We have the one from Milvus. So feel free to take those. Who is HNI? Okay, cool. Yes, you can come to me later after. Thank you. I'm going to do that one because I love this game. Who is Arunav Konvar? Yes, cool. You can also come to me after. And otherwise, that's kind of it for me. Thank you, everyone, for coming. Google will give a talk quickly. Yes?
Just some closing thoughts. Thanks a lot for coming by also from my side. There are some beers in the fridges over there. And some wine, I think, as well, or some water, or whatever makes you take. So feel free to help yourself, network, and if you have any questions regarding the talks from everyone, and then just approach the speakers. Or stick around if you have any talks regarding Google, what we're doing here, how we can help you from GCP side build all this stuff on the cloud. Feel free to approach me, and yeah, look out for more of these meetups.
Thank you, everyone. See you.